Welcome back. Today we're going to be looking at metaclasses in Python, which I find are extremely interesting, but they're quite a lot of dark magic. So before we look at metaclasses, we should probably look at classes. And what you see here is the definition of a square in C++. You can see it's got these functions, area and perimeter, and it's just got this attribute length. And then we could actually define that in Python and say that we have a square. Literally, we don't assign it a length, and then it has an area and a perimeter method. The only thing is in C++, if we tried doing this line where we print square, then it would not work at all, and it would give us errors saying that you can't print classes, because in C++ your class is a template. It's a way of creating objects, but somehow in Python you can print it. And that's because a class is itself an instance, and so it's an object. But it's still a class because it's capable of creating objects, which is what makes it a class. You can do other things like with this, like you can assign it to variables, you can copy it, you can edit the class midway through, so give it a new attribute or a new function, and you can kind of just throw it around. And so we could have this dynamic class where we here create a triangle, here we create a circle, and we just choose a shape and create it. And so it's chosen triangle, and it tells you where it's defined and given us an object. But technically this isn't dynamic because we've defined circle with the word class. And so dynamic creation I like to think of a bit like lambdas. So here we have this function f which returns x squared, and we have exactly the same function called g. It's just written as a lambda, so it's technically a dynamic function. Because here I could have some other variable called k which edits this, whereas here I've used the def keyword. And the way you do that is with type. And so initially you think type just tells you the type of something, and it does. So it tells you the type of one, type of square, and the type of square. And so it's kind of interesting that the type of one is an int, the type of one is a string, but the type of square is a type. And that kind of makes sense because square is this class which we're using to create certain types, and then the type of square is a square because it's an instance. But type actually does this other thing where you take in a name, bases an attribute, and it creates a class. So to demonstrate that, we're going to create this class called constants. And you can see that it's just pi, which is a constant, and e, which is a constant, and they're both rounded to 2 decimal places, so that I don't have to type them all out. And so we print the class, and then we print instance of the class, and then we can do it dynamically. And so we have exactly the same thing as before, and these classes are exactly the same. The only difference is that they're in different memory addresses. And we can even inherit from that. And this is also going to have pi, phi, and e because it's inherited them. So this takes us on to metaclasses, which is the stuff that creates classes. So you have a creator class that creates classes, and your object, which is the thing you create using that creator class. And I think this is a lot like wrappers for functions, where you have a wrapper, and then your function creator creates functions with that wrapper. And this is where it's nice to see actually the class of everything, because everything in Python has a class. So you can see, the class of 5 is int, the class of 5 is string, float, and then we've got this function here and a square. But then, we might want to say, what's the class of the class? Because that would be quite interesting. And all of these classes have class type. And so obviously the natural thing now is to find actually the type of class is. And we can see that type has a type or class of itself, which is a bit confusing. But that's because type is the main metaclass in Python. And so the thing that has created, for example, the string function is this metaclass type, and it's created a string, and so a string is an instance of type, and then we've used that string to create this actual string 5. So when you actually instantate a metaclass, first it looks for the metaclass, then it looks for the parent metaclass, because it's worth noting that metaclasses are not inherited, and then it just uses type. But you can also use the global metaclass if you set one. And initially when you just do that, it doesn't really do anything, but you can set it like that. But now we can create our own metaclass, which is nice to do, and it's not particularly complicated. It takes in all the attributes, and it will either leave them as they are, or it will make it uppercase and have the same value. And so then our type has the same class name that it would in the future, because it has to have the same arguments as type. It would have this future class parents, so if it has any parents, we're going to copy those, and then it would use the new uppercase attributes that we set. And then we can run this with our new class, and you see when we set the metaclass to upper attribute, all the things in our class are uppercase, which don't start with 2 underscores, and that's this attribute. And so that's quite cool. And we could make it do more complex stuff, but it's nice to see that it can do some simple things. But having a metaclass as a function feels like cheating. So instead we can define a metaclass that's a class. And you can see we overwrite the new function. And there are examples where you might have to then overwrite other functions if there are small issues. And so we use our upper attribute metaclass. So this is the actual class, because when you call new, you need to put the class in. And then we take the future class name, the future class parents, and then the future attributes. And then we take the attributes and make them all uppercase. And then when we call it eventually, we use super to call the parent, which in this case is type. And we call the new method with our uppercase metaclass, function class name, future parents, but the new sets of attributes. And technically you could change one of these in your metaclass, and of course that would be quite complicated. And we can now do that, and we see that attribute is uppercase again. So this has worked. So metaclasses are very useful to do black magic, and they look very complicated, but if you think about what they do, when you're creating the class, they intercept it, they modify it, and return the modified class. So it's not that complicated. It's more the using them and making them do things that are useful that are complicated. And I like the fact that metaclasses are deeper magic than most people would ever worry about. And if you ever want to ask why you need them, then you don't. You'd only need them if you knew with certainty that they were the thing to do. Although there is this example in the Django where you've defined this person class which inherits from model, and so uses the metaclass either of model or of the superclass. And you see the name is this character field, and the age is this integer field. But the thing is, when you have this person who has a certain name and a certain age, and you print their age, it gives you back an integer rather than an integer field. And that's not just the print function, but anytime you use the age. And so to summarize, not just by looking at metaclasses, but by all classes, classes are instances of a metaclass. So everything is an object in Python, whether it's an int, a class, a function, and they're all instances of classes or instances of metaclasses, except for type, which is its own metaclass, which is incredibly cool, but also a bit weird. And the way that's done is some very difficult but clever implementation where they've cheated very slightly, but it gives us this language that is completely object oriented in a kind of unthinkable way. Hopefully you've enjoyed this video. You won't use metaclasses unless they're absolutely essential, but you've learned some cool things, not just about classes and metaclasses, but about Python itself. Because, if you want to use Python, you probably want to understand it.